The first element on the periodic table with the symbol H and atomic number 1, hydrogen is the lightest and most occurring chemical element in the universe. Hydrogen exists in stars, such as the Sun, and can be found in water and organic compounds on Earth. Normally, it is a colorless, odorless, non-toxic, and highly flammable gas that produces water when reacting with oxygen and air. Nearly all of the world's current supply of this gas comes from fossil fuels, and the three main methods for producing hydrogen gas are steam reforming, partial oxidation of hydrocarbons, and water electrolysis. Hydrogen can be used to produce electricity and generate heat in fuel cells, produce the intense heat needed to produce steel, cement, glass, and chemicals, and convert unsaturated fats and oils to saturated fats and oils through a reaction known as hydrogenation, in which hydrogen is added to various substrates. Storing and distributing hydrogen fuel can be costly due to its explosivity and large volume. Second on the periodic table with the symbol He, helium is a colorless, odorless, and non-toxic gas that is the second lightest and second most occurring element in the universe after hydrogen, but is rare on Earth. Helium is the first in the noble gas group due to its tendency not to react with other chemical substances. It has the lowest boiling point among all the elements and liquefies when cooled at 4.2 kelvins at atmospheric pressure, remaining a liquid even at the temperature of absolute zero. Helium does freeze at high pressure, requiring a temperature of 1 to 1.5 kelvins at about 25 bar of pressure. Most helium in Earth's atmosphere escapes into space, and any helium on Earth comes from radioactive decay. The best known use of helium is filling balloons, but the largest use is cooling superconducting magnets in medical MRI scanners. A funny effect of inhaling helium is a high-pitched voice, but inhaling too much can be dangerous since helium displaces the oxygen needed for normal respiration. Number 3 on the table with symbol Li, lithium is an alkali metal which is normally the least dense metal and solid element. Being an alkali metal, it is highly reactive and flammable and must be stored in an inert atmosphere. Lithium is less abundant in the universe than other elements due to it being destroyed by low temperatures and lack of common processes to make it. It is also rare on Earth because its high reactivity prevents it from naturally occurring. The lithium that does exist mainly comes from brine and ores. It has been used to make batteries for electric cars and mobile devices. Lithium oxide has been widely used in ceramics, acting as a flux for processing silica and leading to improved glazes on ceramics. Special handling is needed for lithium metal as it is corrosive, and breathing in high amounts of lithium compounds can cause the lungs to build up with fluid. The fourth element with symbol Be, beryllium, is a steel gray, hard, and lightweight alkaline earth metal. It occurs naturally only in combination with other elements to form minerals. While it is found in over 100 minerals, most of these are uncommon to rare. Beryllium is most commonly extracted from the mineral beryl, being a difficult process due to beryllium's affinity for oxygen and ability to reduce water. After beryllium is extracted, it can be used in radiation windows for X-ray tubes because of its low absorption for X-rays. Because of its light weight, stiffness, and stability through different temperatures, beryllium metal is used for structural components in aircraft, spacecraft, satellite, and the James Webb Space Telescope. On average, a small and non-lethal amount of beryllium is found in the human body, but too much exposure to it can lead to lung disease, resulting in disability or death. The fifth element with symbol B, boron, is a metalloid, meaning it has a mixture of metal and non-metal properties. It is brittle and dark as a crystal and brown as a powder. Boron is rare in the universe and does not appear by itself on Earth. It is usually found in compounds such as borax and boric acid. Boron is mostly extracted from ore and minerals to be used for producing glass and ceramics. It is also being studied for potential medicinal applications like treatment for brain tumors. For plants, boron is necessary for maintaining the integrity of cell walls, while more research is needed to understand the full effects of boron on animals. Number 6 on the table with symbol C, carbon serves as a common element of all known life due to its high abundance, diversity of organic compounds, and unusual ability to form polymers at the common temperatures on Earth. It can exist in different forms such as graphite, one of the softest known substances, and diamond, the hardest natural substance. Carbon is found in the Earth's atmosphere when combined with oxygen and carbon dioxide. Carbon has varied uses, such as forming alloys with iron, as a molding material in glass making, and when it is graphite, it can combine with clay to form the lead in pencils. Generally, carbon has low toxicity to life on Earth, but inhaling large amounts of carbon black can cause lung disease. The seventh element with symbol N, nitrogen, is a common element in the universe and makes up 78.1% of the Earth's atmosphere. It is usually produced from air through a technique known as pressure swing absorption, in which nitrogen is separated from a mixture of gases under pressure. As a gas, nitrogen is mostly used to modify the atmosphere where oxygen could pose a hazard. This modification is also used to preserve the freshness of packaged or bulk foods. In chemical analysis, nitrogen can concentrate and reduce volumes of liquid samples by causing solvents to evaporate while leaving solutes and unevaporated solvents behind. As a liquid, nitrogen cools things to low temperatures, such as preserving biological materials and cooling heat-sensitive electronics like infrared detectors and X-ray detectors. While nitrogen gas is non-toxic, it can displace oxygen when released into an enclosed space and cause asphyxiation. Ingesting liquid nitrogen can lead to severe internal damage. The eighth element with symbol O, oxygen makes up almost half of the Earth's crust and is highly abundant in the universe. Under normal circumstances, two oxygen atoms will bond to form the gas dioxygen, or O2, which is used by animals for cellular respiration. If O2 is split by ultraviolet radiation, trioxygen, or ozone, would be produced, which is damaging to lung tissue. Naturally, oxygen is a result of photosynthesis, in which plants convert light energy into chemical energy. O2 can be produced through the common method of fractional distillation of liquefied air, which separates oxygen gas from nitrogen gas, and by the method of passing clean, dry air through a pair of zeolite molecular sieves, which absorbs the nitrogen and leaves behind mostly oxygen. Oxygen is essential for respiration, and oxygen sublimation is used in medicine, modern spacesuits, and certain aircrafts for emergencies. Commercially produced oxygen has industrial uses such as aiding in the process of smelting iron ore into steel, reacting with hydrocarbon ethylene to help with the manufacture of products such as plastics and fabrics, and as an oxidizer in rocket fuel. At elevated partial pressures, oxygen gas can be toxic and lead to health problems, and rapid combustion can proceed where the gas is concentrated. The ninth element with symbol F, fluorine, got its name from its primary mineral source, fluorite. Under normal conditions, it is a pale yellow gas with a pungent odor. Fluorine is extremely reactive as it combines with metals, nonmetals, metalloids, and noble gases that are not light. Fluorine can be produced through electrolysis and stored in special steel cylinders. A major use of fluorine is producing inert insulators for high-voltage transformers and circuit breakers. In dental care, fluoride, a negative ion of fluorine, is used to fight decay and is included in toothpaste. In its normal form as a gas, fluorine is highly toxic, causing more damage to humans the more exposure there is, eventually resulting in death. The 10th element with symbol Ne, neon, is a noble gas that is normally a colorless, odorless, and inert monatomic gas. It is the fifth most abundant chemical element in the universe by mass and is relatively rare on Earth due to its lightness and inertness. Neon is produced from the air in air separation plants which purify it from other gases. A well-known use of neon is in lighting, where it is contained in glass tubes to produce a bright reddish-orange light when electricity passes through it at low pressure, with these tubes formed into different shapes and letters for signage and art. While lights with other colors are called neon, they use different noble gases or varied colors of fluorescent lighting. The 11th element with symbol Na, sodium, is a highly reactive metal that is soft and silvery white. This high reactivity prevents it from being found by itself but in many minerals such as halite and zeolite. Sodium is produced commercially through the electrolysis of molten sodium chloride, or common salt. Millions of tons of compounds with sodium are produced annually. It is an essential mineral to people as it regulates blood pressure, blood volume, and pH. The main source of sodium in diets is sodium chloride, being used as seasoning and preservative, though too much consumption can lead to health problems such as high blood pressure and cardiovascular disease. For certain plants, sodium acts as a micronutrient that aids metabolism. Pure sodium explodes when exposed to water due to the formation of explosive hydrogen and dissolving sodium hydroxide, causing a fire. The 12th element with symbol Mg, magnesium, is a shiny gray metal with a low density, low melting point, and high chemical reactivity. It occurs naturally only in combination with other elements, being found in more than 60 minerals, though only a few are of commercial importance. The most common method to produce magnesium is called the Pidgeon process, in which the mineral dolomite is fed into a heated reduction tank and then thermally reduced to metallic magnesium. As the third most commonly used structural metal, magnesium has been used for aluminum alloys, removing sulfur in the production of iron and steel, and the production of titanium. Because of its low density and mechanical and electrical properties, magnesium is also used for manufacturing mobile phones, laptops, cameras, and other electronic components. In biology, magnesium is essential to the functions of all cells of all known living organisms and to the actions of more than 300 enzymes, with good sources including nuts, cereal, and vegetables. When magnesium is in its pure form or powder form, it is highly flammable when molten and produces ultraviolet light that can permanently damage the eyes unless eye protection is worn. The 13th element with symbol Al, aluminum, is a soft and non-magnetic metal that resembles silver in color and has the ability to reflect light. It is more prevalent in the Earth's crust than in the universe at large because it becomes bound into rocks. Aluminum has a strong affinity for oxygen, which causes it to be found more in oxides or silicates than in its elemental state. The production of aluminum starts with a process called the Bayer process, which converts bauxite rock into alumina, which is then converted into aluminum through the Hall-Héroult process. Aluminum is also recovered through recycling, such as with aluminum cans. Cans and foils are made from aluminum because it is non-toxic. It is also used in transportation because of its low density, in certain building and construction projects when lightness and corrosion resistance are important. Normal exposure to aluminum has little chance to be harmful to people, but is toxic to fish in acidic waters and reduces plant growth on acidic soil. The 14th element with symbol Si, silicon, is a metalloid and semiconductor that is a hard and brittle crystalline solid with a bluish-gray metallic luster. It is the second most abundant element in the Earth's crust behind oxygen and is found combined with other elements in rocks and minerals. Pure silicon is made by reducing quartzite or sand in an electric arc furnace. Compounds with silicon are mostly used as structural compounds, such as making cement, glass, ceramics, and the concrete used for most of the largest building projects in the modern world. The fact that it is a semiconductor makes it essential in the electronics industry, aiding in the manufacture of solar cells and devices used in computers. Plants such as rice use silicon and its compounds to help with growth. Pure silicon is hazardous if inhaled and may lead to lung issues. The 15th element with symbol P, phosphorus, is a solid that exists in several forms, with the two most common being white phosphorus, which is highly toxic and flammable, and red phosphorus, which is stable and less dangerous. It is produced for commercial use by first mining phosphate rock and then treating and purifying it. Red phosphorus is used for the strips of safety matches to prevent accidental ignitions. White phosphorus is used for weapons in the military such as incendiary bombs and smoke screens. In biology, inorganic phosphorus in the form of a phosphate is essential to all known forms of life as it plays a major role in the structure of DNA and RNA. Living cells use phosphate to transport cellular energy for every cellular process. The 16th element with symbol S, sulfur, is a yellow crystalline solid under normal conditions. In nature, it may be found as itself, but is commonly found as sulfide and sulfate minerals. Sulfur is produced from petroleum, natural gas, and fossil resources through hydrotreatment where it is separated and removed. It is converted to sulfuric acid, which is used for extracting phosphate ores, refining oil, and processing wastewater. Pure sulfur is a common fungicide and pesticide, being dusted and applied to crops. Sulfur is an important part of all living cells and can be found in plant and animal proteins. When sulfur is burned, it emits a distinct odor and, when combined with atmospheric water and oxygen, produces sulfurous acid, which is a component of acid rain. The 17th element with symbol Cl, Chlorine is a yellow-green gas at room temperature and is highly reactive. It is common in the forms of chloride salts and ions in seawater. Elemental chlorine is commonly produced through the electrolysis of sodium chloride in brine, a process known as the chloralkali process. It is a common disinfectant and has been directly used in drinking water supplies and swimming pools to keep them sanitary by killing bacteria. Chloride ions are essential for metabolism and the production of hydrochloric acid in the stomach, with the common dietary source being table salt. In its pure gas form at high concentration, chlorine is poisonous to most living organisms, attacking the respiratory system, eyes, and skin. The 18th element with symbol Ar, argon, is a noble gas that is colorless, odorless, and inert. It is the third most abundant gas in Earth's atmosphere and is extracted from air industrially by a process called fractional distillation. Argon's inertness allows it to be used in high-temperature industrial processes, such as arc welding and processing sensitive materials, as anything reactive might cause defects. It is also used to fill incandescent lights to preserve filaments at high temperature from oxidation. Argon's higher density than air makes it a dangerous asphyxiant in closed areas. The 19th element with symbol K, potassium, is a soft, silvery white metal which is highly reactive to oxygen and water. It is mined from rocks and minerals as salt and then separated from sodium and magnesium compounds through different methods. Ions of potassium are essential components for plant nutrition, being used as fertilizer in agriculture and horticulture. In living things, potassium is necessary for the function of all living cells, influencing multiple physiological processes such as blood pressure control, fluid and electrolyte balance, and growth regulation in plants, with major food sources for people including bananas, potatoes, nuts, and bran. Potassium's high reactivity to oxygen and water causes it to ignite, so it needs to be stored carefully. The 20th element with symbol Ca, calcium, is a silvery metal that is most commonly found on Earth as the compound calcium carbonate in rocks and minerals. After pure calcium is produced, it is used industrially in steel making, improving the castability, cleanliness, and mechanical properties of the steel. Calcium is essential to people as it aids in the development of bones and the synthesis and function of blood cells, with the main food source of calcium being dairy products such as milk, yogurt, and cheese. Metal calcium causes corrosive irritation when in contact with bodily moisture and can be fatal if swallowed. The 21st element with symbol Sc, scandium, is a soft and silvery white metal that is relatively rare on Earth and found in trace amounts in many minerals. Its rarity limits its commercial uses, which include strengthening aluminum alloys and being used with these alloys in minor aerospace industry components and sports equipment such as baseball bats and bicycle components, which rely on lightweight materials. The 22nd element with symbol Ti, titanium, is a strong and lightweight metal that is silver in color and resistant to corrosion from seawater and chlorine. It is found as oxides in most igneous rocks and minerals and is extracted through processes such as the Becker process, in which a form of titanium dioxide is produced from the ore ilmenite, and the Hunter process, in which pure metallic titanium is produced by reducing titanium tetrachloride with sodium in a batch reactor at high temperature. About 95% of all titanium ore is refined into titanium dioxide, a powder used in paints, paper, and toothpaste. This powder is also used in sunscreens because it reflects and absorbs UV light. Because of its strength and resistance, titanium is used in aircraft, naval ships, spacecraft, and race cars. The 23rd element with symbol V, vanadium, is a hard, silvery gray metal that is rarely found in nature, occurring in about 65 minerals and fossil fuel deposits. It is harder than most metals, with about 85% of produced vanadium being used as a steel additive, making it stronger. Vanadium compounds are used as catalysts in the process used to make sulfuric acid and to carry charges in flow batteries due to their bulkiness. Vanadium is used in several species of marine algae to aid in defense by regulating hydrogen peroxide produced by photosynthesis. Compounds have moderate toxicity and are poorly absorbed through the gastrointestinal system, and inhalation results in negative effects on the respiratory system. The 24th element with symbol Cr, chromium, is a shiny gray metal with high corrosion resistance and hardness. From compounds found in chromium-containing rocks that eroded, Pure chromium is produced through a two-step roasting and leaching process in which chromium is separated from iron. 85% of chromium is used in producing stainless steel and chrome plating, in which a layer of chromium is placed on metal to provide added resistance or decoration. Oxides are used as a green pigment in glassmaking and as a glaze for ceramics. Chromium metal is not considered toxic, but its compounds are and cause allergic reactions and promote the development of cancer. Thanks for watching.